Previously we have discussed about RC Wien bridge oscillator. Now we are discussing about RC phase shift oscillator. Because we are using the RC circuits, this is also audio frequency oscillator, but Wien bridge oscillator frequency is range from 1 Hz to 1 MHz. This RC phase shift oscillator frequency range is 1 Hz to 10 MHz. But both these RC circuits are able to generate the audio frequency signals 20 Hz to 20 kHz in a very better way. In the RC phase shift oscillator, we are taking 3 RC networks in the feedback. Each RC network is generating 60 degrees phase shift. So the total phase shift by these 3 RC networks is 180 degrees. And the output of this RC phase shift network, again we are feeding to inverting terminal. You see here, this output we are feeding to inverting terminal. That's why now the operational amplifier is working as an inverting amplifier. So here we are giving 180 degrees phase shift because of this feedback network, and the op-amp is giving 180 degrees phase shift. Total phase shift is 360 degrees. 180 degrees phase shift we are getting from the op-amp, and 180 degrees phase shift we are getting from the feedback network. Each RC is giving 60 degrees phase shift. The phase shift can be calculated by using the formula phi is equal to tan inverse XC by R. What is the capacitive reactance here? What is the resistance value here? Based on that, we can calculate the phase shift. So the phase shift here is 60 degrees, 60 degrees, 60 degrees, totally 180 degrees. The gain will be calculated by using this RF and R1. What is the gain of this circuit? Minus RF by R1, because we are operating this as an inverting amplifier. If we want to make A beta is equal to 1, then the gain A is equal to minus RF by R1. Initially the A beta should be greater than 1, and for sustained oscillations A beta should be equal to 1. In order to maintain A beta is equal to 1, we can design these RF and R1 values accordingly such that this circuit works as a audio frequency oscillator. The resonance frequency of this RC phase shift oscillator is given by 1 by 2 pi RC root over 2N. R and C values are the RC values of this feedback network, where N is representing the number of RC networks. Here in this case, number of RC networks are 3. Therefore, the resonance frequency is 1 by 2 pi RC root 6. If we use 4 RC networks, then each RC network's phase shift should be 45 degrees. Then accordingly, the resonant frequency we get is 1 by 2 pi RC root over 8, because we are taking 4 RC networks at that time. But generally we study by using the 3 RC networks only. If we take 2 RC networks, then the phase shift of each RC network should be 90 degrees. This is how we calculate the resonant frequency of the RC phase shift oscillator.